rational equations. Cool. We did that yesterday. In fact, from your questions from the homework, you didn't ask me about the really tough ones here. You were asking me about some that were like a step back. And like I said, that kind of tells me I need to add one of those to the notes. Take out some of the really tough stuff and add one of those. But it also said, use rational equations to solve problems. Here they come. You know, the rational equations that we use generally are for a little bit tougher thinking type of word problems. And this one says we've got a flight across the U.S. and it takes longer east to west than it does west to east. Why would it do that? Start thinking. Well, it must be the wind. So with one of the directions they're going, the wind must be behind them, helping them, pushing them a little bit. And with the other direction, it's fighting against them. So it says assume that the winds are constant in the eastward direction. Okay, so from west to east, from San Francisco to Chicago, this is when they're going to get pushed. Right there. Because they're in an eastward direction. So if that wind is behind them, it's helping them out. And then when flying eastward, the tailwind increases its speed. Well, yeah, duh. So the time for the round trip is shown. Well, as it says up here, when flying westward, the headwind decreases the airplane speed. Of course it does. They're pushing against it. So Chicago to San Francisco, that wind is going to, I'm just going to use the word resist them. You know, it's going to be forcing against them as they're going through this. So what do we know? Well, they're telling us it takes 1,850 miles to go from San Francisco to Chicago. Do you think that changes when they head back? No, you know, it's the same path. And it says the time for a round trip shown at the right is 7 3/4 hours. If the airplane cruises at 480 miles per hour, what is the speed of the wind? Yeah, this is one of those problems. You know, it's where you have to think a lot about what's going on. But it's not difficult if you start here. There's one total in all this information that they gave us. One total so far. Find it. Because that's a one-way trip. There's one total that they flat out gave us. 7 3/4 hours. So I'm going to start with my total. I'm not going to use 3/4 as we go through this. This is going to have decimals. It's a real life problem. So we're going to use 7.75. Now here's the deal. That's hours. So whatever I put as the equation for this has to be about hours. Hours is time. Let's see. That's a distance. We have stuff about hours, which is time. And what would this be called? Miles per hour is a speed. Don't we have some little teeny equation that looks with distance and speed and time? Distance equals rate times time. Oh, where am I going to put this? Distance equals rate times time. I think I'm going to need that space. So now, if my total is about time, I have to use the other information to say this time plus this time equals 7.75. But this isn't solved for time. How do I get time by itself? So this says if I take the distance and I divide it by the rate, then I'll be calculating time. Okay, so what am I adding together? Well, there's two different distances, and well, not two different distances, but two different rates here. We've got San Francisco to Chicago, where the wind is pushing it. And then we have Chicago to San Francisco, where it's resisting it. So I have to do two separate time pieces, but both of them are going to use the 1850. So there's my distance for San Francisco to Chicago. Did it say how fast they were going? was also helping them out, right? Do we know how fast the wind was blowing? Ooh, that's what we're trying to find. If it's pushing it, it's adding to it. They originally had a speed of 480, but now we're going to have to add x to that. All right, now let's think about backwards trim. Obviously, it's still 1850. They didn't say they changed the way that they traveled at 1850 there. And they're still trying to travel at 480 miles per hour. But here's the problem. The wind is holding them back. Now, it said we're supposed to think that the wind is constant as we go through this. So if we do plus x when the wind is helping them out, what are we going to do when it's fighting? Minus x. And these two give us that round trip time of 7.75. So this plus this equals 7.75 because time equals distance divided by rate. Well, that doesn't look like the most pleasant equation we will ever work with, but we have calculators, so get them out. Alrighty, what do we need to do? Just did it in the homework. Least common denominator. It's not a very least common denominator, is it? Yeah. So our LCD, 480 plus x and 480 minus x. Just pushing that in because I'm going to need the room to solve this. So, because I need the room, what I'm going to do is recognize that the 480 plus x is just going to cancel out, and I'm just going to write the 480 minus x here. And here the 480 minus x is going to cancel out, and we'll have to multiply by 480 plus x. And then we're really bad. We're going to need them both over here. All right, away we go. So we'll have 1850 times 480 minus x plus 1850 times 480 plus x equals 7.75 times 480 plus x times 480 minus x. And there's no way I'm going to be able to fit that there. So let's get started. Some big numbers. So 1850 times 480. 888,000 minus 1850x plus, well, good news is we already did the math for this one too. 888,000 plus 1850x. That's even better news. Those two are going to cancel right out. Equals 7.75 times, well, here's some good news. That's a sum and difference pattern, so we just have to do first times first and last times last, or 480 squared. 230,400 minus x squared. So let's simplify a little bit. We're going to need the 888,000 twice. Oh goodness. That's a whopper of a number there. 1,776,000 equals, well, 7.75 times 230,400. 1,785,600 minus 7.75 x squared. What does that mean? So let's subtract here and see what we get. 1776000 minus 1785600 equals negative 9,600 equals negative 7.75 x squared. Little division. I'm just going to leave it like that for a second. Because, again, what we're realizing here is this is not going to be factored. At the beginning, this looked really bad. I mean, factoring with those numbers would be absolutely horrible. All right, so now what? Little square root action. Second square root of that answer. Let me get this. Now, notice we should do the plus or minus piece here, but would a negative really make sense? No problem. Not really, so we'll stick with our 35.195 blah 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 here, and that's our win. So what should we put for speed for our win? Label? Now if that were our answer, big sigh of relief at this point. Did they want to know how fast the wind was going? Good. Now most of the time that's not what they're really going to care about. What they're going to care about is how fast are they going. So how can we tell them how fast they're going? Would that be difficult at this point? No, we're just going to put them in. Say, well, we'll score 80 plus 35.195, and this would be 480 minus 35.195. All right. Now, that was a toughie. Yeah. Yes. You got it? It's much easier. But I'm going to ask. 43210. If I asked you to do the got it for the partner right now, where do you think you're at? Okay, well then maybe we better do the got it together. Now, why is it easier? Smaller numbers. That one had monster numbers, and that's real world. Real world is monster numbers. It just happens. But this one's a little easier. You're riding your bike. You can't ride your bike as fast as they can fly plane. So you ride your bike to the store 4 miles away to pick up things for dinner. When there's no wind, you ride at 10 miles per hour. Today your trip to the store and back took you 1 hour. What was the speed of the wind today? So what do we start with? What's our total? 1 hour. Now we just got done saying distance divided by rate equals time, right? Did they give us the distance? What is it? It's 4. Do we know how fast you're going? 10 miles per hour. On the way there or on the way back, the wind was with you, right? So how did that affect your 10 miles per hour? You added it, yep. And then on the return trip, what happens to your 10 miles per hour? Yes, meets that resistance of the wind. So, much nicer numbers on this one. Multiplying by 10 is always nice. What's our LCD? Both of those monsters, yep, again, I'm not necessarily going to write all of that down, but I realize this would cancel, and I'd have to multiply by the 10 minus x. This would cancel, and I'd have to multiply by the 10 plus x. And unfortunately over here, we would need them both, but it's a sum and difference pattern, so it goes really fast when you multiply it out. All right, let's distribute. stuff taking place there anywhere? What do you see? Well, that's kind of good. All right, so negative 4x plus 4x is gone. So it doesn't look so bad. So now what do we do? Subtract 100. Divide by a negative 1. Then what? A little square root action. Square root of 24 and some change. Did anybody punch it in already? 4.47, blah, blah, blah. Plus or minus, right. We should think of that. But since we're talking about the wind here, probably just want to say the positive speed, right? No, it's good to think about it, but we should stop and think about that every time we do the square root with the plus or minus piece. And did they just want to know how fast the wind was? Cool. We're done. Again, we could tell them how fast we were traveling in each direction. We have that already up here with the 10 plus x and the 10 minus x. So now, if the numbers are more like this, 4, 3, 2, 1, 0, how do you feel? Numbers much better when they're, yeah. Okay, good, good. Your 4, 3, 2, 1, 0 is much improved with the small numbers here, which is good. These are things we should be able to do. Now, interesting question. B says, explain why there's no difference between the travel time to and from the store when there is no wind. No resistance. Yeah, it's not pushing you and it's not pulling you back. So if there's no wind, this becomes a much easier problem, you know. But the reality is there's wind of some kind or another that we have to deal with. Now, unless it would be totally calm, which yeah, almost never happens.
Still, you haven't meant to sort that. There's still a little bit of wind. I mean, there could be like 0, 0.
So this last thing is not my favorite. Because what it's going to do is it's going to say, what if we told you you had to use your graphing calculator? And I don't like that because I punch things in. So what I have to do is be really, really careful with this. And they do want us to use Blinky. They want us to say, hey, everything on this side, y sub 1. Everything over here, y sub 2. Just so that I know it's not just me. How many of you would rather solve it algebraically? Yeah, I just handing it over to the graphing calculator is just not something I've never been comfortable with. But here's what we have to know. If there's more than one thing in the numerator or the denominator, it has to have parentheses. The calculator doesn't know what to do with it otherwise. So we are absolutely going to need parentheses here and here. And that's because it does follow the order of operations. So we need it to do the division first and then the addition, which it will do. But if there were x's in my numerator, I would also have to have parentheses for those. So let's give it a try. See if we can make our window right and have everything work out here. Yeah, because if you have time on this test, you probably want to check your answers. Window-wise, especially on the test, we generally try to keep this like a negative 10. But for our y's, look at what we want to see. We just want to see 1. So we probably don't need to do negative 10 to 10. We can maybe just do 0 to 3. Ready? So hyperbolic.
No, it's like just way more curved. It's not just like a
Your window's not the same then.
They're different windows. I didn't see six.
Okay. So that's what we see. So it looks like 0. is our x value. But we could use the table feature. In the 30s, but it's zero. I always do table set. Well, then that's our answer. Because we wanted a y value of 1. But is 0 a viable answer for this problem?
Yes.
It is, yeah, because take a look at it. It's not going to make our denominators equal to 0, so it would be just fine. Now, if you're looking at that thinking, what's up with the y sub 1 and y sub 2? Remember, we put in 2 different functions here, and the second one was just 1, so it makes sense that that's what we see. All right, so that was just kind of a bear to punch in. Let's see this one. That doesn't look so bad. I definitely will not do this one with the graphing calculator.
This one would be so.
All you have to do is multiply, but they want us to do this, so we have to tell the graphing calculator parentheses up here, parentheses here. We have to. Or it will not do it right. And it is a great way to check and make sure that your answers are right once you solve them. What do you think about our window? Anything we should change? Something I have to change. What do I have to change? Yeah, I have to be able to see 5. And maybe we'll just go to 7.
It's all reals.
Well, let's see. So, second table. Uh-oh. It looked like it was right around 0. But it's not perfect. So this time I need to get Blinky in the picture. Second trace, number 5. All right, Blinkster. Right in there. Enter. And right on that line, enter. Uh-oh.
0.7.
It is. Why didn't I grab it?
It should be like. Second tree 5.
Huh. So I went to the left and it took it. It just didn't like
Second
the
tree
position.
5.
Second trace 5. Then make sure Blinky's on the curve for the hyperbola. Hit enter. Make sure Blinky's on our y equals 5 line. Hit enter. So, 0.27 repeating. Cool.
2727.
There it is. Again, I wouldn't use the calculator. You know, I'd solve them algebraically and check with the graphing calculator, but it's always good to check. So, how do you feel about the graphing calculators here? Or if you had to do it, 43210, would you make it happen?
I can teach that to someone.
All right, so we could make it happen.
But I
Not
refuse
necessarily
to use the
happy about it,
graphing calculator.
but we could do it.
It'd be hard to apply the graphing calculator. Oh my! Oh my! No. No.
Yeah, remember what I said about next year.
Can I take a picture of that?
Yeah, and it'll be, I'll put it on the completed notes too. Because most of this is just the extra instructions here. So 21 to 29 odd, solve them algebraically, even if it has a little calculator icon. I to do that, solve them algebraically. 36 to 39, and then 41, only do A through C. The